to what they said with their big data. Now, this one says, what is the probability, what is the percent that I have at least 12.19 ounces? So now we're doing the curve, the shading. Am I going to shade above or below 12.19?
Above.
Because if I want at least $12.19 in my pocket, that means I want 12.19 or above. If you want at least $12 in your pocket, you want $12 or more. You with me? So I take that same picture. Oh, can't show you that. So we go to our calculator and we're going to do the normal CDF because we're doing shading. What is my left limit?
12.19.
12.19. What is my right limit? 9.99. What is my mean?
12.
12. What's my standard deviation?
102.
0.02. So I go to my calculator. Now, let me show you how it looks in your calculator. If I do second bars, normal CDF, my lower limit is 12.19, my upper limit is 9.99, my mean is 12, and my standard deviation is 0.02.
Your lower is wrong.
It didn't go. It went. Yeah.
What's she do?
Normal CDF, 12.19. Now, some of y'all, when you do your homework, I'm going to go ahead and tell you, you're going to email me because you're going to type in and you're going to whoop-whoop that the answer is 106.7. And you're going to say, Miss Cooper, why is this wrong? Well, number one, what is the whole curve? 100%. So how can the answer be 106? You with me? This is less than 50%. Do you agree? This e to the negative 21. E to the negative 21 means times 10 to the negative 21, which means take your decimal and move it 21 times. So your answer is really 0.0000000000000000000000006. So what's your answer? Thank you very much. You with me? So what is the probability? What are the chances that we get a 12-ounce Coca-Cola with 12.19 ounces in it? It ain't gonna happen. We may get 12.03, 12.05, but we ain't gonna get 12.20 ounces. Y'all with me? They gonna give us just a little jug, but they ain't gonna give us a swallow. Does that make sense? So when you look at your answer, that right there tells you how many times you're moving your decimal to the left. So our answer is really 20 zeros followed by that number. They put it in scientific notation.
So that's what it means when E combines.
Right, that E is scientific notation. Yeah, that E is not an error for this one. Now the question says, does it appear that customers are being cheated? Yes or no? Coca-Cola says when they average all their Cokes, they average 12 ounces. Well, we go by our Cokes and we average 12.19 ounces. Are we being cheated?
No.
We actually get more than we should be getting. So are we being cheated?
No.
No, we're actually getting more soft drink than what we're supposed to be getting based on our sample. So they're telling us that we're supposed to be getting 12, but when we went and bought it, we got 12.19. So we're not actually getting cheated. We're actually getting more than we should have gotten. You with me? All right, this goes back to what we did again, very first day of class. I said, the people in this class, fill out your index card. 75% of y'all had a cell phone. So that was 75% of my class had a cell phone. And then I told you that the margin of error is 5%, that was your wiggle room. And you wiggled off of that mean, and that came up with your confidence interval. And I said, if 75% of my sample has a cell phone, then I'm going to assume that 70 to 80% of my population has a cell phone. So we went from the sample to the population. Remember that? That's when y'all started to think I was crazy. So we took our mean, the average of this class, we wiggled off of it, and then we went to the population. We're going to do the same thing. The only difference is you're going to calculate the error to come up with this. And I am recording today's lecture. Yeah. So, 8.2. This shows you in statistical language what I just did. If I take an X bar, which is the sample mean, and I take the E, which is the margin of error, and I wiggle off of that, I'm going to get X bar plus E and X bar minus E, which is the mean plus the error and the mean minus the error, and that's going to give me my confidence interval. Same thing I just said, they just had to make it look harder than it was. Now, this is another margin of error formula. This is a margin of error formula if you know the sample mean. Before we were doing the error formula if you knew the population. So when we were doing the error before, we knew the population standard deviation. Now we're doing the standard deviation of a sample. So we're going to do 2 times the sample standard deviation divided by the square root of the size of the group. And you're going to have all of this in your notes. Don't freak out. We haven't talked about, you only have 2 questions on your exam. So don't freak out on me. So, let's look at some examples. Let me cover up. All these formulas are on your formula sheet. We're even going to spend next week talking about 5 pages of formula sheets. Which ones do you need to know for the exam? Don't look at any of the other ones. I'm going to get very specific. Cover this up. All right, this problem says, assume that the population means are estimated from the samples. So use the sample to approximate the margin of error and find the confidence interval. So there's 49 people in my class. The average of my class is 25, and the sample standard deviation is 2.2. So the first thing we have to do is find the error. So the formula for error, let me write it a little bigger. Error equals 2 times standard deviation over the square root of the size of the group. So it's going to be 2 times, what's my standard deviation of this class?
Standard deviation 2.2.
2.2. And how big is the group?
49.
So I go to my calculator, and I'm going to do 2 times 2.2 divided by, and we talked about it last time, but just in case you forgot, the square root button is above the squared button. So we're going to do second square root of 49. So my error, and my math lab will tell you what to round it to. I'm just going to say, I don't know what I said. I rounded it to 6.3. So my error is going to be 6.3. That's going to be my wiggle room. In the beginning of the semester, I told you what that error is. You're now going to have to calculate it. Because y'all were a little bit smarter than you were when I first mentioned. Just a little bit. Now, we're not done. We're not done because all we did was approximate the error. Approximate the error. Now, it wants us to find the confidence interval. Did you get it, bud? And when I do it in 2 steps. I work out the top, I get an answer to the top, and then I divide that top answer by bottom.
The error is always 2 times the same, always.
2 times the standard deviation divided by the size of the group. So my error is 6.3. So I've got to wiggle off of what? Which of these numbers am I wiggling off of?
The mean.
The mean. So I'm gonna add 0.63 and subtract 0.63 off of the mean. So I'm gonna come down here, I took my mean, I color coordinated it for you. I took my mean and I wiggled off my mean. So I did my mean plus the error and my mean minus the error. That gave me my confidence interval. So we're still doing the same thing, we're just adding in that extra step of you having to find the error. 2 times the standard deviation divided by the square root of the size of the group gives you your error, and then you wiggle your error off of the mean. Now, just to show you, this is the book's answer. Yeah. X bar plus or minus E is 25.2 plus or minus 0.6 is blah, 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 blah. It's the same thing as what I'm doing, okay? But that's what the book's gonna tell you.
Okay.
And I'm gonna upload all of this so that you'll have it over the break. While everyone's in here, and I know some people are copying, I have the 5-point duties from Mariana, Natavia, Brittany Ward, Justin, Joe, Judy, Iris, and Sydney. So those people got their 5 points added to that last test. And you also got, I went and reviewed everybody's test yesterday. I was too lazy. I did not send out individual emails, but if you want to know which problems I gave you credit for, I have them all written down. But most of you are just like, let me see my final grade. But if you go into my math lab, you can see your new grade. And that is the points that were added from me looking at it and your 5 points. Okay, so if you want to know what it was before, these people just take your 5 points off. But those are the people that I added 5 points to. I also opened up all homework until Tuesday of next week. So if there's any homework that you did not get 100 on, you need to go back there. If you choose to, if you're happy with your grade, that's fine. But if you want to go out there and bump anything up, you can do that as well. I'm hopefully going to finish close to getting finished. Okay, I'm done with this page. Let's go on. Okay, now this problem. It says, okay, we have 81 people in the class. The average of y'all is 4.5. The standard deviation is 3.1. It says give the margin of error and then find the confidence interval, which means wiggle off of that. So we're going to do 2 times the standard deviation. So it's going to be 2 times 3.1 divided by the square root of 81, because there's 81 people in the group. We cool?
Mm-hmm.
Oops. So it's going to be 2 times 3.1, and then we're going to divide that by the square root of 81. And again, my math lab will tell you what they want to round it to. I called it 0.7. So that was from right here. That's where I got the 0.7 from. So that's my wiggle room. That's my left and right. What do I wiggle off of?
4.5.
The 4.5. You always wiggle off the average, off the mean. So I'm going to do 4.5 plus the error and 4.5 minus the error. So if I come down a little bit, I took my 4.5, which was my mean, and I added the error and I subtracted the error, and that gave me my confidence interval. So I'm going from my sample information to my confidence information, which is my population. And I've worked several of the, and then I put the book stuffed out there. But I have worked, I gave you the data and I gave you the answer. I gave you another problem and I gave you the answer worked out. So I gave you several out here. It's really just plugging into the formula. It's not, I don't know how to change that. But it's just, I gave you several out here if you want to practice to use like for your notes and stuff. That one we really don't need. Okay, this one, let's cover up and talk about this one. This one didn't give you a picture. It says you live in a neighborhood and there's 62 houses in the neighborhood. So this is group data because you have a group of 62 houses. The average weight of plastic that you throw away is 1.91. So they're telling you that the mean is 1.91. The standard deviation is 1.07. Use a single value to estimate the average weight. Well, y'all, whether it's individual data or whether it's group data, what is the mean always going to be? 1.91. So 1.91 is your mean no matter what. Okay? So the answer to that one is going to be 1.91. And now, so that was the first question. The second question says find the confidence interval. Well, before we can find the confidence interval, we got to find the margin of error. So my error is going to be 2 times standard deviation divided by the square root of the size of the group. So it's going to be 2 times
1.07.
1.07 divided by square root of
62.
So if I come down, the average of all households, that was the first answer, is 1.91 because it doesn't matter if it's individual or grouped. First thing we have to do, my watch is fussing at me, telling me I need to move. All right, for this one, before we can get our confidence interval, we have to find our error. So 2 times standard deviation divided by the square root of the group, size of the group. I multiply, and then I divide. So I called my error this time, I did it to 2 places. I called it 0.27. Okay, I do whatever I feel like. My math lab will tell you what to do. So now this is going to be my wiggle room. What am I wiggling off of?
1.91.
The mean, 1.91. So we're going to do 1.91 plus the 27 and 1.91 minus the 27. So 1.91 plus the 0.27, 1.91 minus the 27. Remember, the left is going to be the smaller one, the right is going to be the bigger one. There's your answer. Cool? Now, this next problem, then I could probably give you an exam on this one problem that's coming up next. Love it. Love, love, love this next problem. Hold on. Oh. Love this next problem. It says the health of a bear is monitored by measuring bears that are being put to sleep, because you don't just ask them how much they weigh. A sample of the bears is given below. Estimate, find the confidence interval. So y'all, we just want to know confidence interval. Piece of cake. Well, right here, they're telling you the weights of the bears. They give you a bunch of weights. That's all you have. How much the bears weigh. We want to know the confidence interval. Well, in order to know the confidence interval, do you agree that we have to know the error? Well, the formula for error is 2 times standard deviation. Well, do we know the standard deviation?
No.
Divided by the square root of the number of people in the group. So we've got to count how many weights we have. So we've got to know that. We've got to know the standard deviation. Well, then we'll have the error. Well, what do we wiggle off of? The mean. Do we know the mean?
No.
So y'all, this is such an awesome problem because they gave you data and they didn't give you anything else. So you have to know the error to wiggle off the mean, but they didn't give you any of that stuff. So there's 36 numbers here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 36 numbers here, so we know that 36 is our n. But the formula for error is E equals 2 times S over square root of n. So we had to count the numbers to figure out the n is 36. We don't know what the S is. We don't know our standard deviation. We don't know our mean. So we've got to figure out things before we can do the problem. So let's go back in our brain, which makes this a good review problem. Let's go back in our brain and figure out how do we find the mean and how do we find the standard deviation?
Stat edit.
Okay, so we would go to stat edit. So stat edit, we would go to the top, hit clear enter, and go to the top and hit clear enter. Do we have one set of data or two sets of data?
One.
We have one set of data. We just have a bunch of numbers. Now, I'm not going to type them all in. I'm just going to type a several in just so that I can go through the process. 44, 32. I'm just going to type in the first two columns. So pretend I typed in all 36 pieces of data. What would I do next after I type it in L1? Stat. Calc.
Enter.
Now, you only know how to do two things. You only know how to do number 1 and number 4.
Number one.
It's a one. It's a one.
Number 4 is where we did the y equals ax plus b. That's where you got two lists. That gave you the r value and the r squared value. The test y'all all just screwed up. That's your y equals ax plus b. This was when we didn't know much and we only had one list. That's why it's called the one variable. Joe is giving Judy the hand.
Yeah, because
Joe's like, sorry, Joe. Judy's about to beat him up. One of our stats is when we had that one list of data. That's when we didn't know anything but simple stats. So we're going to choose the one, and we're going to hit enter, enter, enter. This is where we get the X bar, so our sample mean, the mean of our sample data, which mine's wrong because I didn't put all the data in there, and then our SX, which is our sample standard deviation, and then our N would be 36 because we would have 36 pieces of data in there. So I wrote right here, they did not give us a sample mean standard deviation, so we have to find it so that we can get the error, so that we can get the confidence interval. So I'm kind of putting it in there. We did stat, edit, list 1, then we did stat count, then we ran one of our stats. So I worked it all out for you. Oh, look, it's pink. Oh my gosh. That will be new for next semester. So I typed in all my data. I had 36 pieces of data. Then I did one of our stats. There's my sample mean. There's my sample standard deviation. There's my. So now I can do error. The formula for error is 2 times standard deviation. So 2 times this divided by the square root of 36. I color coordinated it for you. I didn't do that whole thing. I just did a couple places behind the decimal. So 2 times that divided by the square root of 36 gives me my error. That's my wiggle room. And what am I wiggling off of? What color? The purple, the mean. I'm wiggling off of the mean. So 183 and some change. So I did 183 and some change minus the error, 183 and some change plus the error. How stinking awesome is that problem?
That was nice when you do it.
I know. That was cool. All right. Now, for this problem, oh, this is a good one too. This one talks about, and y'all actually asked me this earlier in the semester. I don't remember who. I want to say it was you. When you said, like when you're doing a sample and you say, how do you know how many people to ask? What is a big enough sample? Or like when you roll a die, how do you know how many times to roll it? What's a good enough number?
Above 55, is that what you said?
So this is a formula. It's called N, the number of people. How many people do you need to ask in a survey in order to get the confidence interval you want? So the formula is N equals 2 times standard deviation. This time we're talking about population standard deviation. 2 times standard deviation divided by error, and take that whole thing and that squares it. So if you want to work backwards, if you want to say, I want to do a survey, and I want it to be this good. I want it to be really good. Then you can work it backwards and say, I have to ask this many people in order for it to be this good. Because if you only ask 5 people, it's probably going to suck. But you can work it backwards to figure out how many people do I need to ask for me to have a stinking awesome survey. So, 2 times the standard deviation divided by the error, and then square that answer. This will tell us how many people we need to ask for the survey. And the question says, find an estimate of the sample size. So how many people do we need to ask? What does our size of our sample need to be? how many people do I need in my survey? So the formula was N equals 2 times the standard deviation divided by the error. So for this problem, 2 times my standard deviation divided by my error. Now, when I do this problem, I do 2 times this, then I divide by this, then I square it. I do it in like 3 different parts. So just to show you how I work it out. It was 2 times 20 divided by 5. So I did 2 times 20, got an answer. Then I divided it by 5, got an answer, and then I squared the whole thing. I don't try to type it in as 1, because sometimes you'll get it screwed up. So I need to ask, in order for me to have a margin of error of $5 with a standard deviation of 20, I need to ask 64 people. So it's like figuring it out backwards.
Is that gonna be on the test?
I don't know, we're fixing all that. Here's another one, and these are really just plug and chug. Plug and chug. You plug it in and you chug it in your calculator. So my standard deviation is 95.2. My error is 18.2. So I multiply the top, get an answer. Then I divide it by the bottom, get an answer, and then I square the answer. Now, y'all,
Square again?
okay, I'll work on this one whole out. So it's going to be 2 times 95.2, get an answer. Divide by 18.2, get an answer. And you can do to the second power, get an answer. Now, can we have 109.4 people?
No.
We can't have 0.4 per person. We can have 109 or we can have 110. For this one, it's going to be 109. You have to have a whole person. You can't have part of a person. That has to be a whole number because you're talking about people. Now, I did put a couple more out here if you want to try them, but those are strictly plug and chugs. Here's another one that's like a real life. A media research company wishes to estimate how the average number of hours that high school students spend watching TV. The margin of error is 0.25. Past studies suggest that the standard deviation is 1.7. Estimate the minimum sample size. So how many students do we need to ask? So it's going to be 2 times what? These are your only 2 things, and you know E stands for error, so what's this going to be?
1.5.
1.7 divided by
0.25.
0.25, and then
Square.
squared, which is also known as to the second. So if I come over here, I'm going to do 2 times the 1.7, get an answer. Then I'm going to divide it by the error, which is 0.25, get an answer. Now, you can always do to the second, but there's also the little button that's squared that means to the second. So I can do it that way as well. Now, am I going to type in 184.96?
No.
No, because we're talking about people. What am I going to type in?
185.
185. Now, there it is. I have given you all of my mathematical knowledge for 165. How does it feel? Now, I do have, for some reason, I have this problem out here. So last semester, somebody must have asked me this about a homework question. So because they asked me, I'm figuring y'all may want to know. So this was chapter 5 homework number, what does that look like, y'all? 38 maybe? It says systolic, whatever, blood pressure for women between the ages of 18 and 25 has a normal distribution with a mean of 113.7 and a standard deviation of 12.58. What is the likelihood that it's 125 or above? Now, y'all, a lot of people on your test miss questions because y'all woot-woot when you shouldn't have woot-woot. It didn't say give me a percentage, it said write a decimal to 4 decimal places. So I gave y'all full credit when y'all, like the answer was .1234 and y'all wrote 12.34. So just pay attention to, if it doesn't say give me a percentage, you don't need a woot-woot. So for this one, it says what is the likelihood. It doesn't say percentage. So give it to them as a decimal, don't give it to them as a percent. So We're doing mean, standard deviation, my data's 125 or above. Are we good?
Yeah.
My left is 125, my right is 999, my mean, my standard deviation, I type it in. They don't want a percentage. They want it to the hundreds. Hundreds is 2 places. So this would be 0.18. Y'all with me? Now, this